What if Earth's magnetic field suddenly reversed in a single day? Picture this. You wake up tomorrow morning, check your phone, and your GPS is completely wrong. Your compass spins wildly, pointing in impossible directions. Birds are flying in confused circles overhead, and whales are beaching themselves by the thousands. The aurora borealis, those beautiful northern lights, are suddenly dancing across the sky in broad daylight, visible even from Miami and Los Angeles. What I just described isn't science fiction. It's what could happen and what has happened when Earth's magnetic field suddenly reverses. And here's the thing that'll keep you up at night. Scientists believe we might be living through the early stages of such a reversal right now. Welcome back to Javis Heist, where we dive deep into the mysteries that reshape our understanding of the world. I'm your host, and today we're exploring one of the most mind-bending phenomena our planet has ever experienced: magnetic pole reversals that happen not over thousands of years, as textbooks tell us, but in a single day. Now, before you start checking your compass app, let me tell you a story that begins 42,000 years ago. During what scientists now call the Lachamp event, a magnetic reversal so dramatic and so fast that it nearly wiped out early human civilization. Imagine you're a Neanderthal living in what we now call Europe. The year is approximately 40,000 BCE. You've spent your entire life navigating by the stars, following animal migration patterns that have been consistent for generations. Your people have developed sophisticated cave art, created complex tools, and built a thriving society. Then, seemingly overnight, everything changes. The animals you hunt begin behaving erratically. Caribou that should be migrating south are heading east. The birds that usually signal seasonal changes are flying in confused patterns. Even more terrifying, the very sky begins to betray you. At night, brilliant sheets of light, what we now know as auroras, cascade across the heavens in colors that shouldn't exist this far from the poles. This isn't mythology or ancient folklore. This actually happened, and we know because of a remarkable discovery made in 2021 by a team of researchers studying ancient kauri trees in New Zealand. Dr. Chris Turney from the University of New South Wales was examining tree rings from these ancient giants when he noticed something extraordinary. The trees, which had lived through the Lachamp event, showed massive spikes in radiocarbon levels. Levels so high, they suggested Earth's magnetic field had weakened to just 6% of its current strength in a matter of decades, not millennia. But here's where it gets really interesting. When Turney's team cross-referenced this data with ice core samples from Greenland and sediment records from around the world, they found evidence that the magnetic field didn't just weaken gradually. It appeared to have multiple rapid flips, some occurring within a human lifetime, others possibly within a single year. To understand why this matters, you need to grasp something most people never think about. Right now, as you're listening to this, you're surrounded by an invisible force field that extends tens of thousands of miles into space. Earth's magnetic field isn't just some abstract scientific concept, it's literally the only thing standing between you and a universe trying to kill you. Every second of every day, our sun hurls billions of charged particles toward Earth at speeds exceeding 1,000,000 miles per hour. This solar wind, as scientists call it, should strip away our atmosphere, boil our oceans, and turn our planet into a barren wasteland like Mars. The only reason we're having this conversation is because Earth's magnetic field deflects most of these particles, creating a protective bubble around our world. But what happens when that bubble suddenly pops and reforms facing the opposite direction, Doctor? Alan Cooper, who led the 2021 study on the Lachamp event, described it to me in terms that still give me chills. He said, and I'm paraphrasing here, that during a rapid magnetic reversal, Earth essentially becomes a sitting duck in a cosmic shooting gallery. The atmosphere gets bombarded with radiation levels hundreds of times higher than normal. The ozone layer, which protects us from deadly ultraviolet radiation, can be depleted by up to 60% in a matter of years. Now, you might be thinking, okay, that sounds bad, but humans survived the Lachamp event, right? And you'd be correct. But here's what keeps me awake at night. We barely made it. The archaeological record from around 42,000 years ago tells a haunting story. This period, which coincides perfectly with the Lachamp magnetic reversal, shows evidence of massive environmental upheaval across the globe. Cave art suddenly explodes in frequency and complexity, as if our ancestors were desperately trying to record and make sense of a world gone mad. In Australia, the last of the megafauna giant kangaroos, massive wombats, and other incredible creatures vanished from the fossil record. In Europe, Neanderthal populations, which had survived ice ages and countless other challenges, finally went extinct. Some researchers believe the magnetic reversal created a cascade of climate changes so severe that it pushed multiple species over the edge. But the most chilling part? We now know that modern humans nearly joined them. Genetic studies of human DNA suggest that around 42,000 years ago, the global human population crashed to potentially fewer than 10,000 individuals. That's not 10,000 inches, a single region that's 10,000 people on the entire planet. We came closer to extinction than most people realize, and it happened right when Earth's magnetic field was doing backflips. Doctor. Cooper's research team found that during the Lachamp event, cosmic radiation increased so dramatically that being outdoors during certain periods would have been like getting multiple chest X-rays every hour. The auroras, those beautiful lights I mentioned earlier, weren't just pretty displays, they were visible signs of our atmosphere being literally torn apart by charged particles from space. And here's the kicker. Tree ring data suggests that some of these magnetic field changes happened incredibly fast. We're talking about the magnetic poles moving thousands of miles in a single year, possibly even faster. In 2019, a team of researchers drilling ice cores in Greenland made a discovery that changed everything we thought we knew about magnetic reversals. Deep in the ice, at a depth corresponding to approximately 41,000 years ago, they found a layer unlike anything they'd seen before. The ice from this period contained massive concentrations of cosmogenic isotopes, essentially the atomic fingerprints of cosmic radiation. But it wasn't just the quantity that shocked them, it was the pattern. The isotopes appeared in sharp, distinct bands, suggesting that whatever had caused them had happened very, very quickly. Doctor. Sanja Panowska from the German Research Center for Geosciences told reporters that the ice core data was consistent with a magnetic field reversal occurring in less than a human generation, possibly in just a few years. Think about that for a moment. Everything we've been taught about magnetic reversals taking thousands of years, it might be completely wrong. But if you think that's unsettling, wait until you hear what happened in 1859. The 1st of September, 1859, started like any other day for telegraph operators across North America and Europe. By evening, It had become what many consider the most terrifying glimpse of what a rapid magnetic event could do to our modern world. Richard Carrington, a British astronomer, was observing the sun through his telescope when he witnessed something extraordinary, a massive solar flare erupting from the sun's surface. Within hours, that wave of charged particles reached Earth and collided with our magnetic field. What happened next sounds like something out of a disaster movie. Telegraph lines across 2 continents began sparking and catching fire. Operators received electric shocks so severe that some were knocked unconscious. In Boston, telegraph wires sent showers of sparks cascading onto the streets below. But here's the really weird part. Some telegraph systems actually worked better during the storm, drawing power directly from the aurora-charged atmosphere. People in the Caribbean could read newspapers by the light of auroras visible in broad daylight. Gold miners in the Rocky Mountains woke up at 2 a.m. thinking it was sunrise. The sky was so bright with northern lights. The Carrington event, as it's now known, lasted less than 2 days. But imagine if, instead of a temporary magnetic storm, Earth's entire magnetic field had suddenly weakened and reversed during that time. Every electrical system on the planet would have been fried. And in 1859, we barely had any electrical systems to worry about. Today, we have satellites, GPS networks, power grids, internet infrastructure, and billions of electronic devices. A Carrington-level event happening during a rapid magnetic reversal wouldn't just be inconvenient. It could send civilization back to the Stone Age overnight. Here's what really keeps geophysicists up at night. We still don't understand how or why rapid magnetic reversals happen. The traditional explanation that Earth's magnetic field is generated by the slow movement of molten iron in our planet's core simply can't account for changes happening in years or decades instead of millennia. Dr. Brad Singer from the University of Wisconsin has spent his career studying volcanic rocks that preserve ancient magnetic orientations. His work has revealed evidence of magnetic field changes that happen so fast they challenge our fundamental understanding of how planets work. In 2014, Singer's team published findings showing that during some ancient reversals, the magnetic field moved at rates exceeding 6 degrees per year. That might not sound like much until you realize that the current rapid movement of our magnetic North Pole, which has been accelerating dramatically over the past few decades, is moving at about 3.3 degrees per prime year. And that brings us to the elephant in the room. What's happening to Earth's magnetic field right now? Since systematic measurements began in the 1,840 seconds, Earth's magnetic field has been weakening. Not gradually, not subtly, but at an accelerating pace that has scientists genuinely worried. Over the past 150 years, the field has weakened by approximately 10%. In some regions, particularly over the South Atlantic, it's weakened by up to 25%. But here's what's really alarming. The rate of weakening is increasing. The European Space Agency's Swarm satellite mission, launched in 2013 to monitor Earth's magnetic field in unprecedented detail, has revealed something that sounds like science fiction but is very real. There's a massive weak spot in our magnetic field stretching from Chile to Zimbabwe called the South Atlantic Anomaly, and it's growing rapidly. Satellites passing through this region regularly experience computer glitches and system failures due to increased radiation exposure. The International Space Station has to shut down non-essential systems every time it passes through this area, which happens multiple times every day. Dr. Jürgen Matzke from the German Research Center for Geosciences monitors global magnetic field data 247. His team's measurements show that magnetic north is currently racing towards Siberia at about 35 miles per year, the fastest recorded movement in over 400 years. But it gets stranger. The magnetic field isn't just weakening uniformly, it's developing multiple poles. Right now, Earth has areas where compasses point in completely different directions depending on where you're standing. It's as if our planet's magnetic system is having an identity crisis. Remember those confused animals I mentioned at the beginning? That's not hypothetical. It's happening right now, all around us. Marine biologists have documented a dramatic increase in whale and dolphin strandings over the past 2 decades, particularly in areas where the magnetic field is weakening most rapidly. These creatures navigate using Earth's magnetic field like an internal GPS, and when that GPS starts glitching, they literally lose their way. Sea turtles, which use magnetic navigation to travel thousands of miles across oceans, are showing up in places they've never been found before. Arctic terns, those incredible birds that migrate from pole to pole every year, are increasingly flying off course. Even more disturbing, researchers studying bird migration patterns have found that some species are beginning to change their migration routes in ways that correspond almost exactly with magnetic field anomalies. It's as if the natural world is trying to tell us something we're not quite ready to hear. In 2018, a controversial paper published in the journal Nature proposed a theory that, if true, would revolutionize our understanding of rapid magnetic reversals. Dr. Christopher Davies from the University of Liverpool suggested that these events might be triggered by massive changes in the flow patterns of molten iron deep within Earth's core. According to Davies's model, certain conditions can cause the metallic fluid in our planet's outer core to suddenly reorganize itself, like a river changing course overnight. When this happens, the magnetic field generated by this flow can flip direction in a matter of years or even months. But here's the really unsettling part. Davies' calculations suggest that once this process begins, it becomes self-reinforcing. The magnetic field weakens, which allows more cosmic radiation to penetrate our atmosphere, which heats up the upper atmosphere, which can actually affect the flow patterns in Earth's core through complex electromagnetic interactions. In other words, a rapid magnetic reversal might not be a random event. It might be the inevitable result of a planetary system pushed past a critical tipping point, and some scientists believe we may have already passed that point. There's a question that most researchers in this field don't like to discuss publicly, but it haunts their professional conversations. What if the Lachamp event wasn't a natural magnetic reversal at all? In 2020, a team of atmospheric physicists published a paper suggesting that the rapid magnetic changes 42,000 years ago coincided almost perfectly with the explosion of a massive star somewhere in our local galactic neighborhood. This supernova, they argue, could have bombarded Earth with enough high-energy particles to temporarily disrupt our planet's magnetic field generation. The theory is controversial because it implies that rapid magnetic reversals might be externally triggered events, not internal planetary processes. If true, it means that another nearby supernova, which astronomers say is statistically inevitable within the next 100,000 years, could trigger another rapid reversal that we'd be powerless to predict or prevent. Of course, not all scientists buy into this theory. Dr. Gauthier Hulot from the Institute of Earth Physics in Paris argues that the supernova connection is purely coincidental and that rapid reversals are simply a normal, if rare, behavior of Earth's magnetic field system. But even Holo admits that our current understanding of magnetic field dynamics is incomplete. As he told a conference of geophysicists in 2019, "We're essentially trying to understand a Ferrari engine by listening to the sound it makes from outside the garage." Here's something that might surprise you. Despite all the evidence for rapid magnetic reversals in Earth's past, there's remarkably little public discussion about what would happen if one occurred today. Government emergency management agencies don't have contingency plans for magnetic field collapse. The Federal Emergency Management Agency's disaster preparedness guidelines mention earthquakes, hurricanes, and terrorist attacks, but magnetic reversals don't appear anywhere in their documentation. This silence isn't accidental. When I reached out to several government scientists for this episode, most declined to comment on the record. The few who agreed to speak did so only on the condition of anonymity. One NASA researcher told me, "We know enough to be worried, but not enough to make useful predictions." That's a very uncomfortable place for a scientist to be. The uncomfortable truth is that if a Lachamp-style event happened tomorrow, there's very little we could do to prepare for it, and even less we could do to prevent it. There is one glimmer of hope in all this uncertainty. The same satellite technology that's allowing us to monitor Earth's magnetic field in real time might also provide our early warning system for rapid reversals. The SWARM mission I mentioned earlier, along with ground-based magnetic observatories around the world, now provide a level of monitoring that would have seemed impossible just a few decades ago. We can track changes in the magnetic field's strength and direction with unprecedented precision. Dr. Nils Olsson, the scientific director of SWARM, believes that if a rapid reversal begins, we'll see warning signs at least a few years in advance. Magnetic field models show characteristic patterns that precede major changes, and our monitoring networks are sensitive enough to detect these early indicators. But here's the catch. Even with several years of warning, there's no clear consensus on what humanity should actually do. Hardening electrical grids against electromagnetic storms is possible but enormously expensive. Protecting satellites from increased radiation requires completely redesigning our space-based infrastructure. And there's no feasible way to shield the entire planet's ecosystem from the kind of cosmic radiation bombardment that occurs during magnetic field collapse. Some researchers have proposed ambitious geoengineering projects, essentially creating an artificial magnetosphere using massive space-based magnetic coils. But these concepts remain firmly in the realm of science fiction, at least for now. As I've been researching this episode, one pattern keeps emerging that I find deeply unsettling. Every major extinction event in Earth's history, the one that killed the dinosaurs, the Great Dying that eliminated 90% of all marine life, the mysterious extinction that nearly wiped out early human ancestors, shows evidence of magnetic field instability occurring at roughly the same time. This could be coincidence. Correlation doesn't necessarily imply causation, as any scientist will tell you. But the pattern is striking enough that a growing number of researchers are beginning to suspect that magnetic reversals might be one of the primary mechanisms by which life on Earth gets periodically reset. Dr. Andrew Roberts from the Australian National University has spent years studying magnetic minerals in sediment cores from around the world. His work reveals that major magnetic field disruptions occur roughly every 200,000 to 300,000 years, and we're currently about 780,000 years overdue for a full reversal. That timeline should give you chills, because it suggests that not only are we living during a period when Earth's magnetic field is behaving abnormally, but we're living during a period when it's statistically likely to undergo a major change. There's another piece of this puzzle that mainstream science has only recently begun to take seriously: indigenous oral histories that describe events remarkably similar to rapid magnetic field reversals. Aboriginal Australian stories, some of which are believed to be over 40,000 years old, describe a time when the sky fell and the ancestors' paths in the sky were broken. These stories often include descriptions of unusual aurora activity, animal behavior changes, and navigation difficulties that align surprisingly well with what we'd expect during a magnetic field disruption. Similar stories exist among Native American tribes, particularly those in the Pacific Northwest. The Makah people have oral traditions describing a time when the world turned upside down and whales beached themselves en masse while the northern lights danced in the southern sky. For decades, anthropologists dismissed these stories as mythology, but as our understanding of rapid magnetic reversals has evolved, some researchers are beginning to wonder if these oral histories might be humanity's oldest scientific records, eyewitness accounts of the last time our planet's magnetic field went haywire. If that's true, then these stories might contain crucial information about how to survive such an event. Indigenous survival strategies, developed over thousands of years of living through extreme environmental changes, could prove more valuable than any modern technology when the next magnetic reversal begins. As I've been preparing this episode, I keep coming back to one fundamental question. If we know that rapid magnetic reversals have happened before, and if we know that one is statistically overdue, why isn't this front-page news every day? Part of the answer is that uncertainty breeds paralysis. When scientists can't give definitive timelines or clear predictions, it's easy for policymakers and the public to focus on more immediate concerns. Climate change, at least, offers concrete data and actionable solutions. Magnetic field reversals remain frustratingly unpredictable. But I think there's a deeper reason for our collective silence about this threat. The possibility of a rapid magnetic reversal forces us to confront the fundamental fragility of our technological civilization. We've built a world that depends entirely on stable electromagnetic conditions, and we've done it during what may turn out to be an unusually calm period in Earth's magnetic history. The thought that our entire way of life could be undone by an invisible planetary process we can't control is profoundly unsettling. It challenges our assumption that human ingenuity and technology can solve any problem we face. As I finish researching and writing this episode, I'm struck by a profound irony. We live in an age where we can measure the magnetic field of distant planets, predict the weather weeks in advance, and communicate instantly with people on the other side of the globe. Yet we remain essentially helpless in the face of a planetary process that has shaped the history of life on Earth for billions of years. The evidence for rapid magnetic reversals is overwhelming. The data showing that our magnetic field is currently weakening and destabilizing is undeniable. The historical correlation between magnetic field disruptions and mass extinction events is deeply troubling. And yet, life continues. We wake up each morning, check our phones, and assume that the invisible magnetic shield protecting us will continue to function exactly as it has throughout human history. Maybe that's not such a bad thing. Maybe the ability to live with uncertainty, to build civilizations and plan for the future despite knowing that cosmic forces beyond our control could change everything overnight, is actually one of humanity's greatest strengths. After all, our ancestors survived the Lashamp event. They lived through a period when Earth's magnetic field collapsed and reformed, when cosmic radiation bombarded the planet, when the very sky betrayed them. And they not only survived, they created art, developed new technologies, and passed down stories that we're only now learning to interpret. The truth is, we don't know when the next rapid magnetic reversal will occur. It could happen tomorrow, or it could happen in 100,000 years. The magnetic field models that seemed so reliable just a decade ago are being revised as new data reveals the complexity of the systems we're trying to understand. What we do know is that Earth's magnetic field is currently behaving in ways that previous generations of scientists thought were impossible. The poles are racing toward new positions, the field strength is declining at an accelerating rate, and weak spots are growing in regions that were stable for centuries. We also know that rapid magnetic reversals have happened before, that they can occur much faster than traditional science suggested, and that they can have profound effects on life on Earth. Does this mean you should start building a bunker and stockpiling supplies? Probably not. The statistical likelihood of a major magnetic event happening in our lifetimes remains relatively low. But it does mean that we're living through one of the most interesting periods in Earth's magnetic history, and we have a front-row seat to observe processes that may not occur again for hundreds of thousands of years. More importantly, it means we're part of a generation that might finally solve one of the greatest mysteries in Earth science. The monitoring technology we have today, combined with improved understanding of planetary magnetic fields, could allow us to witness and understand a rapid magnetic reversal in ways that no previous generation could imagine. And maybe that's the real story here. Not that we're helpless victims of cosmic forces, but that we're the first generation of humans with the tools to truly understand what's happening to our planet's magnetic field. We're the first to read the warning signs in ice cores and tree rings, the first to monitor magnetic field changes in real time, and potentially the first to develop strategies for surviving a rapid reversal. Our ancestors survived the last Champ event with stone tools and fire. If we face a similar challenge, we'll meet it with satellite networks, quantum computers, and a global scientific community working together to understand and adapt to our planet's magnetic behavior. That doesn't mean it won't be terrifying. It doesn't mean we won't face enormous challenges. But it does mean that we're not facing them blind. As I wrap up this episode, I want to leave you with one final thought. The story of Earth's magnetic field reversals isn't just a story about planetary physics or ancient climate change. It's a story about resilience, about the ability of life to adapt and survive in the face of seemingly impossible challenges. Every time you use your phone's compass, every time you watch the northern lights, every time a migratory bird finds its way across thousands of miles of open ocean, you're witnessing the result of a planetary magnetic field that has been shaping the evolution of life for billions of years. That field is changing, right now, in ways we're still learning to understand. Whether those changes lead to a rapid reversal in our lifetime or gradually stabilize into a new configuration, we're living through a moment in Earth's history that will be studied and discussed for centuries to come. The scientists I've spoken with for this episode all share one common trait. They're fascinated by the mystery, even as they're sometimes frightened by its implications. There's something profoundly humbling about studying a planetary process that makes human civilization seem like a brief moment in geological time. But there's also something inspiring about it. Every measurement we take, every model we build, every piece of evidence we uncover brings us closer to understanding one of the fundamental forces that shapes our world. The magnetic field that protects us today isn't the same one that protected the dinosaurs or the early humans who painted cave walls during the Lachamp event. It's a dynamic, ever-changing system that reflects the complex interactions between Earth's core, its atmosphere, and the solar wind streaming from our star. And we're part of that system, whether we realize it or not. Our technology depends on it. Our planet's ecosystem is shaped by it, and our future as a species may well depend on how quickly we can learn to understand and perhaps even influence it. The story of rapid magnetic field reversals is still being written. The data is still being collected, the models are still being refined, and the mystery is still unfolding around us every day. What we know for certain is that Earth's magnetic field has surprised us before, and it will almost certainly surprise us again. The question isn't whether significant changes will occur, it's whether we'll be ready for them when they do. That's our show for today. If this episode has left you with as many questions as answers, then I've done my job. The greatest mysteries are the ones that change how we see the world around us, and Earth's magnetic field reversals definitely qualify. I want to hear what you think about all this. Are we living through the early stages of a magnetic reversal? Should we be doing more to prepare for the possibility of rapid magnetic field changes? Have you noticed any unusual animal behavior in your area that might be related to magnetic field changes? Drop your thoughts in the comments below. I read every single one, and your insights often help shape future episodes. And if you enjoyed diving deep into this mystery, make sure to subscribe to Javis Heist for more stories that challenge everything you thought you knew about our world. Next week, we're exploring another phenomenon that mainstream science struggled to accept: the mystery of ball lightning, and the recent discoveries that suggest it might be far more common and far more dangerous than anyone previously imagined. Until then, keep looking up at the sky, keep questioning what you think you know, and remember that the most important mysteries are often hiding in plain sight. This has been Javis Heist. Thanks for listening, and I'll see you next week.